Consider a boat sailing with a velocity of 3, -2 km per hour. So this is the velocity. So this velocity is actually 3I minus 2j. At 12 hours, the boat is at the position A with the position vector 3, 13 km relative to an origin. Okay, so this OA is equal to 3I plus 13j. Okay, so for this one, I can separate to two parts. So we have the Naughty Elephant split water, and I know that the I is go to the east 1 unit, and the J is go to the north 1 unit. Okay, so this one I can separate to two parts. First part is the I part. So for the I part, they start at, so this is the O, they start at 3, and then they start at 3, yes, and then they go 3 unit to the right every 1 hour. So then we have the 6, they start here, okay, then 3, 6, 9, 12, and so on. Okay, so this is t equal to 1, t equal to 2. Okay, so this one we also have the 12 and 15. So 12, 15, so t equal to 3, t equal to 4. So t equal to 0, then it is 3i. T equal to 1, then it is 3i plus 1 multiplied with 3i. And then t equal to 2, it is 3i plus 2 times 3i. T equal to 3, it is 3i plus 3 times 3i, and so on. So we know that t equal to t, then it is 3i plus t times 3i. It is the x position. Then the y position is the 13 and then minus 2. So we have the 13 minus 2 here. Okay, so you imagine the y position is start at the 13, and then minus 2, then it will be negative 11, negative 9, negative 7, the 13, then we have 11, and then we have 9, 7, 5, and so on. So t equal to 0, t equal to 1, t equal to 2, t equal to 3, t equal to 4. So it goes downward. Okay, 2 unit. Just now this one is go to the right, 3 unit. Okay, so we know that when t equal to 0, it is at the 13j. T equal to 1, it will be 13j plus 1 times negative 2j. T equal to 2, 13j plus 2 times negative 2j. And then t equal to 3, it will be 13j plus 3 times negative 2j. So it is 7, yes. So therefore we have t equal to t, it will be 13j plus t times negative 2j. So we combine these two. Okay, so we combine these two. So the vector position will be look like this. Okay, the position vector will look like this. The diagram for the boot. Okay, the position for the boot. So we combine the x-axis and combine the y-axis, then this will be the position. So we can see that 313 is the first, 313. Then we have this one is the 611. So we have the 611, and then 9, 9, 12, 7, 15, 5. So we have 3, 13, 6, 11, and then 9, 9, and we have the 12, 7, and the 5, 5 here. Okay, so we know that for the x part, it is 3i plus t times 3i, and for the second part, it is the 13i plus t negative 2j. So we combine these two, we can get the position vector. So the position vector will be the 3, 13 plus t times 3 negative 2. So this lead to the general rule. So this is the general rule. So the R equal to A plus TV. So we have the position. This is the position vector is equal to the initial position plus times multiply with the velocity. Okay, so we have the, this is the position vector, that is the position at time t. This is the initial position. This is the time in hour, and this is the velocity. Okay, so this is the formula for position vector. So we repeat. So the initial position is 3, and then every hour at 3i, so we have the 3i plus t times 3i as the x-axis here. Initial at the 13j, and then minus 2j every hour, so 13i minus plus t times minus 2j. So this will be the position vector. So the velocity, okay, velocity normally how to find is depend on, sometimes they will give us speed is the maybe x, okay, maybe we have the speed is s km per hour in the direction of xy. Okay, then we want to find the velocity. Then the velocity will be the speed times the unit vector, square root of x squared plus y squared of this xy. Okay, so this one combined is the unit vector in the direction of xy. Okay, so this is if the question didn't give us the velocity. Instead of give us a velocity, they give us a speed and the direction. Then this is how we find the velocity.